Okay, let's talk about physics. I'm going to say about physics basically what I said about philosophy, that there's no consensus on simultaneous causality in physics, that how you think about the question is going to be a function of what you understand causality to be. Now for physics, you have the additional complication that a lot of people think that the concept of causation actually plays very little, if any, role in fundamental physics. But we'll say more about that later. So let's start the discussion with some simple candidates for simultaneous causation. You imagine a lead ball resting on a cushion, where the weight of the ball causes an indentation in the cushion. The claim is that the downward force of the ball is a continuing event that is causing the continuing indentation, and that the cause and the effect are occurring simultaneously. Another example is the glow of a heated metal bar. We say that the temperature of the bar causes the bar to glow, but these are ongoing processes that are occurring at the same time. Now, if you don't like simultaneous causation, then you're going to argue that this description isn't quite right. When you look at the physics in detail, you'll want to say that what we have here is an equilibrium situation where certain phenomena are occurring simultaneously, but changes in those phenomena, like changes in the weight of the ball or the temperature of the metal bar, don't produce instantaneous changes in the shape of the cushion or the brightness of the light emitted from the bar. There's always a lag between cause and effect, so this isn't really an example of simultaneous causation. Now, another reason for skepticism about simultaneous causality in physics comes from relativity theory. If the world is governed by relativistic principles, then the speed of light is the cosmic speed limit, and there can be no causal interaction between spatially separated simultaneous events. For some people, this is enough to rule out simultaneous causation within physics, end of story. On the other hand, there have been some explicit defenses of simultaneous causation in physics. I dug up a paper from my office files by Michael Huemer and Ben Kovitz called Causation as Simultaneous and Continuous. Their view is that in physics, causal relations are described by the laws of physics, which they interpret as causal laws. So if you look at Newton's second law, for example, it says that changes in a body's state of motion, either speeding up or slowing down or changing direction, are caused by the net forces acting locally on the body, and as the forces change, the body's state of motion changes simultaneously. They also argue that in order to avoid the problem with extended causal chains that I mentioned earlier, if we accept simultaneous causation, we also have to accept that causal processes don't occur at moments of time, but are actually extended over time, so that causes and effects should be viewed as extending over time and overlapping. I'm not going to say anything more about this paper by Huemer and Kovitz, and I'm not endorsing its conclusions. I'm just using it to point out that there are defenses of simultaneous causation in the literature. Now, the last thing I want to talk about is something I mentioned earlier, about a not uncommon attitude that physicists and philosophers of physics have about causation and the role that causal concepts play in fundamental physics. This attitude makes you think twice about the whole notion of trying to ground a theory of causation in physics. What's the attitude? Well, the most famous expression of this attitude comes from the philosopher Bertrand Russell, who wrote an essay in 1913 called On the Notion of Cause, and this is what he writes, quote, "All philosophers of every school imagine that causation is one of the fundamental axioms or postulates of science. Yet, oddly enough, in advanced sciences such as gravitational astronomy, the word cause never appears. To me, it seems that the reason why physics has ceased to look for causes is that, in fact, there are no such things. The law of causality, I believe, like much that passes muster among philosophers, is a relic of a bygone age, surviving, like the monarchy, only because it is erroneously supposed to do no harm." Now, the idea he's getting at is this. The most basic laws and principles of physics aren't framed as causal claims of the form A causes B, but rather as differential equations. And what these equations describe are relations of functional dependency between variables, force, mass, acceleration, charge, momentum, energy, and so on. And what's important about this notion of functional dependency is that, and this has become clearer over the past 100 years, at the most fundamental level, these functions are time symmetric. What this means is that if you take the time variable in these equations and reverse it, the equations still have viable solutions. So the equations themselves don't distinguish between processes running forward in time and processes running backward in time. Now, as a matter of fact, we know that many physical processes that we observe do have a directionality to them. Ice cubes melt at room temperature, they don't spontaneously reform into ice cubes. So we know that irreversible processes enter the picture at some level, and this irreversibility seems to be related in some way to our common sense intuitions about the direction of time. But the puzzle has been how to understand the origins of time irreversibility when the fundamental laws of physics are all time reversible. Now, this is a long-standing question in physics and the philosophy of physics. Many books and articles have been written on it, and there's no consensus answer to this question. So many have concluded with Russell that physics might just be the wrong place to look even for an explanation of the directionality of time and change, much less to look for a foundation for a universal law of causality. Now, I would say that a lot of the recent philosophical work on the relationship between physics and causality seems to accept this pessimistic outlook. But not everyone agrees that physics or science can or should try to get rid of the concept of causation entirely. In fact, most don't. Scientists, including physicists, use the concept of cause and effect all the time. It would be hard to imagine what science would look like without it. So the challenge has been to give an account of causation that acknowledges that our use of causal concepts can't be grounded in fundamental physics, but at the same time seeks to explain and justify our use of these concepts in science and everyday life. I think that on this issue, the focus has shifted to looking at how and why we represent the world in causal terms. And a view that is gaining some popularity is that the naturalness of representing the world in causal terms is best understood as a consequence of our perspective as agents who intervene in the world, make plans and decisions, and so forth. Now, this approach to causation falls into the Humean category broadly construed. Again, I'm not endorsing this view, I'm just trying to describe the state of discussion on these issues as I see them. Now, what's the upshot of all this for the original question, which was about simultaneous causation and its application to the origins of the universe?